Hey students, today's lesson is going to be on solving now two-step equations. So last lesson it was focused strictly on one-step equations, but now I'm going to do two steps to solve these equations. So let's get started. So we recap. Remember how to solve an equation. Get the variable by itself. The whole purpose is to isolate the variables. So you generally want to undo the addition. A lot of the times, I mean, it is a case by case, but most of the time you're going to undo the addition or subtraction first by using the inverse operations of addition and subtraction. They're inverse operations. They undo each other. And then undo the multiplication or division. And remember, whatever you do to one side of the equation, you have to do to the other side to keep the equation balanced. So these lines do help, and you're going to see that in two-step, and then when we do multi-step equations in the next lesson, that the lines help you really distinguish the left and the right side. So what you want to do in a two-step equation is always identify the side the variable's in. Sometimes the variable is going to be on the left side, sometimes the variable is going to be on the right side. And then move or figure out a way to get rid of what is not attached to the variable on that same side. So we're strictly working on the left side right now, okay, of this, because that's where the p is. And right now we have 3 times p minus 4. The 3 is attached to that p first. So you want to do that last. So you want to find a way to get rid of that negative 4, that minus 4 first. So how do we get rid of a minus 4? Subtraction, the inverse operation is addition. So we're going to be adding 4 to both sides. Okay. And that gives us 3p is equal to 11 plus 4 is 15. So this is why vertical like this helps a lot more. I know some of you guys, when I checked your work, were writing it kind of horizontally, but I'm a big fan of this. I think it visually helps to see what you're doing to each step, and it takes up less space, and we don't want too much space. And now this is multiplying, and the inverse operation of multiplying is division, so we're going to divide 3 to both sides. Right, and now the 3's are going to go away. And it's fine if you use a division symbol too, if you like that. I'm so used to using the fraction bar, that's why I do it. And you're going to get p is equal to 5. 15 divided by 3 is 5. Okay, and this really does help. When you draw that line, you can see, because you're going to do now more than this is 2 steps. Excuse me. This is 2 steps, and whatever you do to the left side, you got to do the right side. And let's check our solution. 3 times 5. Sorry, something is stuck in my throat. Minus 4 equals 11. We're going to use order of operations to check this. 3 times 5 is 15. Minus 4 equals 11. 15 minus 4 is 11, so 11 does equal 11. Check. Sorry. All right, next question with a different color. So solve negative 6x minus 1 equals 35. So variable is on the left side. So we're gonna now work to get the x by itself on the left side. So on the left side, what is not attached to that x? That's what you're doing first. And in this case, this is saying negative 6 times x minus 1. So negative 6 times x is actually, the x is attached to the negative 6 and multiplying. First, we have to deal with the minus 1. So we're going to add 1 to both sides, because addition is the inverse operation of subtraction. And then you're going to have negative 6x equals 36. Negative 6 times x is, this is multiplying, so you're going to have to divide negative 6 to both sides. So x is going to equal negative 36 divided by negative 6 is negative 6. And now let's check the answers. So negative 6, you guys know me with my colors, times negative 6 plus 1, I mean not 1, but not plus, let me undo, minus 1 is equal to 35. Negative 6 times negative 6 is 36. Remember, negative times a negative is positive. Minus 1 equals 35. And this is going to be 35 equals 35. Awesome. We are right. Next problem. This time, if you notice, the variable is now on the right side. Okay? So that's what you're working towards. If you add 6 over here, you're going to have a 0 on the left side. And that's not kind of what we want. We want to get the variable on the left side. So in this problem, you're going to have x equals. If you choose to rewrite this, you're more than welcome to rewrite this like 2x minus 8 equals negative 6. This is something you're doing. You're not changing the sign. You're not changing anything. You're just kind of writing what's on the right side on the left side, what's on the right side on the left side, or opposite. You're just kind of just switching these two around, okay, around the equal sign. Anyway, on the right side, we're going to work with it this way. On the right side, what is not attached to the x? And this again, once again, is that subtraction of 8. So we're going to add 8 to both sides. Don't know why I picked all these problems with subtraction, but I did. So that's going to go, the negative 8s are going to cancel each other out. Negative 6 plus 8 is 2 is equal to 2x. Divide the 2. Oops. And you're going to end up getting 2 divided by 2 is 1. So x equals 1. And now let's check our answer. Negative 6 is equal to 2x. Nope, not 2x. What am I doing? We are checking our answer. Times 1 minus 8. So negative 6 is equal to 2 times 1 is 2 minus 8. Negative 6 is equal to 2 minus 8 is negative 6, so we are good. So this is the right answer. And I don't care if you give me answers like this, but some of your teachers might require you to just rewrite it where the variable is on the left side. But that's either one of these is acceptable, okay? Or I'm not picky, but just recognize this means exact same thing. That's equal sign. 2 is equal to 2. 2 is always equal to 2. You can rewrite it around. All right, another type of problem. So the first thing, as always, you want to do is identify the side the variable is on. And on this, the variable is on the left side. And now we have y over 5, y divided by 5 plus 7. What is not attached to the y on that left side? And that is that addition of the 7. So we're going to do the inverse operation of addition. We're going to subtract 7 to both sides. And now these 7s go away. And you're going to have y over 5 is equal to 9 minus 7 is 2. Inverse operation of dividing 5 would be multiplying 5. And I see some of you guys writing the x5. I would avoid that. If you don't want to write the x, if you don't like the parentheses, then I'm more of a fan of using the multiplying with the dot and writing it like that. Instead of using the x, because we're solving for variables, and I don't want you to get, sometimes you're going to have x and then multiplying, and it's going to look the same thing. It's going to be like x times 5. And this, if you don't write it clearly, it gets very confusing. This is just, from experience. The 5s go away. You're going to have y equals 10. And you can go back and check that. 10 over 5, 10 over 5 plus 7 is equal to 9. 10 divided by 5 is 2. 2 plus 7 is equal to 9. 9 equals 9, and it's right. So this is correct, and I'm going to simplify it. Are you going to be required to do that all the time? No, but I do think it's a good habit. Maybe you should stop the video here, pause it, check to see if you can do it on your own, and then check your answers. All right, welcome back. So now we have which side is the variable on? The variable is on the right side this time. So we're going to now on that side look to see what the variable is not attached to. what is the farthest away from it. And in this case, it's the subtracting of 5. This is plus 5, so we're going to subtract 5 from both sides. And then these 5s go away. And you're going to have negative 2 minus 5, or negative 2 plus negative 5, same thing. It gives you negative 7 equals x over 9. And then we have a division over here. That means we're multiplying. So we can multiply 9 to both sides. There is no hope for me. I will always use a parentheses for multiplying. Years of teaching and habit from my teachers growing up. So x is equal to 9 times negative 7 is not 9 minus 7. Remember that. I think I saw that in some of your work. Make sure you realize what you are doing. This is 9 times negative 7, which is negative 63. And let's check our work. It's supposed to be an equal sign. So negative 63 over 9 plus 5 is equal to negative 2. So negative 2 is equal to negative 63 divided by 9 is negative 7 plus 5. Negative 7 plus 5 is negative 2. So this is true. We are right. Okay. This problem over here, once again, variable on the right side. So we're going to be dealing with the subtraction of 2, not the division of 5. If you do the division of 5, if you want to get rid of that fraction first, if you do that, you need to multiply 7 to all of it. Let me show it to you that way. It's not the way that I would like, but if you choose to go this way, you need to multiply that denominator to every single thing that is separated by an addition or subtraction sign. So you're going to end up getting 7 is equal to v minus 14. It's easier when I do it, but I have seen kids do this, and what they will do is this. They will forget to multiply that 7 to that negative 2. 80% of the time, students will forget to do it. This is not I don't prefer it. I think more mistakes happen. I prefer you do it like we did example 4 and 5, but you are welcome to do it this way. And then you can add 14. Okay, and that's going to give you v 21 is equal to v. And you get the same answer. I don't want you to think you don't get the same answer. You get the same answer, whichever way you do it. If you add 2 over here, you're going to have the way you do it over there is going to be 3 is equal to, when you add 2, v over 7. And then you're going to multiply that 7, and you're going to end up getting v is equal to 21. So it doesn't matter which way you choose to do it. You're going to get the same answer. I am definitely a bigger advocate for this is not written neatly. I'm going to erase it and rewrite it. This is 21 is equal to v. I'm definitely, this is my preferred method. All right. But this also works. If you get it, you get it. Let's look at some word problems. Setting up these word problems is not always easy. Aaliyah had $24 to spend on 7 pencils. So we know there are 7 pencils. After buying them, she had $10. How much did each pencil cost? So I'm actually going to do P is cost of each pencil. Okay. So let's see, Aaliyah had $24 to spend on 7 pencils. After buying them, she had $10. Okay, so she's left with $10. You can go about this several ways. So she's left over with $10 at the end. So you're starting off with 24, and you're subtracting 7 times P. Cost is 7 pencils for P costs. I think this is one way you could set it up. You could also do it as, I believe, 7P plus 10 is equal to 24. That would also work. We'll check both ways. Let's solve them both ways. I think these are the 2 equations that I would go by. I'm going to draw that line. And now let's solve. So on the left side, on the left equation, we have 24 minus 7p. So the p is attached to the 7, negative 7. So we're going to be subtracting. Not that minus sign is in front of the 7. Does not be just because the subtraction does not mean you're adding here. Actually, it does not mean you're adding here. This is a positive 24. You have to subtract 24 to get rid of that 24. If you add a 24, this is going to be 24 plus 24. That gives you 48. It does not give you that 0 that you are looking for. And then that's going to be negative 7p is equal to 14. Oh, negative 14. I knew I did something wrong. 10 minus 24 is negative 14. Divide by negative 7. And you get p is equal to 2. So we have 2 pencils. How much does each pencil cost? Oh, pencils are each pencil $2 for each pencil. Let's check to see if it comes to the same answer with the other equation. So in this side, again, the variable's on the left side, which I generally like to keep it, especially when I'm creating an equation. So we're going to subtract the 10. That gives you 7p is equal to 14. Divide by 7. And we get p is 2. So same answer. If you're wondering how we got this equation, 24 is how much you have to spend total. You spent, after buying them, so you know that you had $10 left over. I think this is more intuitively makes much more sense, but this also does work. I think maybe for multiple choice, this is the one that they're going to give you. To me, that makes just the most sense because it tells you how much, after buying them, she had $10. But this is saying how much you spent on the pencils, how much you have left, and the total number of money. You have $24 total. So again, they both work. Just make sure that you understand how they work with each other. All right. Another problem. You bought a magazine for $5 and 4 erasers. You spent a total of $25. How much did each eraser cost? So very similar. You bought a magazine for $5 and 4 erasers. You spent a total of $25. So in this case, you have 4 erasers. How much should each eraser cost? So X cost of each eraser. So this time I actually think this one is more intuitively, it makes sense. You spent a total of $5, so you're going to have total at the end here. And now let's just see how this expression works. You bought a magazine for $5, so 5 plus each, and then you bought 4 erasers, but we don't know what the cost is, so 4 times X. Now let's solve it. Subtract to 5. So you're going to get 4X is equal to 20. Divide by 4. So X equals 5. So each eraser costs $5. Okay. Okay, I think that was it as far as examples go. All right. That was it as far as examples goes. Hope this helps. Bye, everyone.